Hi, welcome to the next section, Text and Numeric Queries. In this section, we'll be using a term and prefix, query. Then move to using wildcard, regexp, and span query. We will then see using match, string, simple string, range, ID, and common terms query. Lastly, we will see function, score, exists, and template query.
Now we move on to the first video of this section that deals with using a term query and prefix query. In this video, we are going to execute a term query as a filter and use it wrapped in the Boolean query. The terms query is extended to support multi-value. We then use prefix query to skip the terms that start with common prefix.
Searching or filtering for a particular term is very frequent. Term queries work with exact value matches and are generally very fast. The term queries can be compared to the equal to query in SQL world for not tokenized fields. We need an up and running Elasticsearch installation. To execute curl via the command line, we need to install curl for our operative system. And to correctly execute the command, we need an index populated with the populate query script. So to execute a term query, first we type this command and execute it from the command line. If everything is alright, the result is this. This query is used for executing a term query as a filter. We need to use it wrapped in a Boolean query. This is the way query is executed. If everything is fine, this is the result. Lucene, due to its inverted index, is one of the fastest engines at searching for a term or value in a field. Every field that is indexed in Lucene is converted in a fast search structure for its particular type. First, the text is split in tokens, if analyzed or saved as a single token. Second, the numeric fields are converted in their fastest binary representation. And third, the date and date time fields are converted in binary forms. In Elasticsearch, all these conversion steps are automatically managed. Search for a term independent from the value, which is archived by Elasticsearch using the correct format for the field. Internally, during a term query execution, all the documents matching the term are collected, and then they are sorted by score. For more details about Elasticsearch similarity algorithms, go to this link. If we look for the results, for the term query, the hit has 0.2876821 as the score. The time required for scoring, if the sample is very small, is not so relevant, but if you have thousands or millions of documents, it takes much more time. The filter is preferred to the query when the score is not important. The typical scenarios are filtering permissions, filtering numerical values, filtering ranges. Term query works well for single term search. If we want to search for multiple terms, we can process it in two ways, using a Boolean query or using a multi-term query. For executing a terms query, we write a terms query and execute it from the command line. This is the result if you type the right command in the command line. Now let's see how the term query works. The terms query extends the term query to support multi-value. This call is very useful because it is very common to the concept of filtering on multi-value. This query searches for UUID with value 33333 or 32222. The terms query is not a merely helper for the term matching function. Now let's take a look at the example. The terms query allows you to define extra parameters to control the query behavior, such as minimum match or minimum should match. This controls how many matched terms are required to validate the query. This query matches all the documents where the color field has at least two values among red, blue, and white.
Think, for example, a user that contains the list of groups in which he is associated, and you want to filter documents that can be seen only by some groups. The pseudocode should be. In this example, the list of groups is fetched at runtime from a document which is always identified by an index, type, and ID and the path field that contains the values to put in it. The routing parameter is also supported. The pattern would be select all, where you can see selected groups with user ID. Generally, NoSQL data stores do not support join, so the data must be optimized to searching via denormalization or other techniques.
Let's execute a prefix query. The prefix query is used when only the starting part of a term is known. It allows completing truncated or partial terms. For executing a prefix query, first of all, type this query in the command line and execute it. This is the results for the prefix query. When a prefix query is executed, Lucene has a special method to skip to terms that start with a common prefix, so the execution of a prefix query is very fast. The prefix query is used in general in scenarios where term completion is required, as name completion, code completion, on-type completion. When we design a tree structure in Elasticsearch, if the ID of the item contains the hierarchic relation, it can speed up the application filtering very much. If it's compared to a standard SQL parent ID table on a very large dataset, the reduction in join and the fast search performance of Lucene can filter the results in some milliseconds compared to some seconds or minutes. Now, what's more, the prefix query can be very handy when you are searching for ending text. The best practice to cut down the time to search for an ending text is to index the file name field with a reverse analyzer. To achieve this, perform these steps. First, we define reverse analyzer to index level, putting this in the settings. Then, after we define the file name field, we use reverse analyzer for its subfield. Now we can search using a prefix query, using a similar query. Using this approach, for example, when you index a file named mytest.png, the internal Elasticsearch data will be similar to these.